This simulation is on the website of Climate Interactive. It's very easy to use. It's based on all the modeling results. What it does very convincingly is it demonstrates the science of zero carbon emissions to stabilize atmospheric carbon dioxide concentration. The only problem with it is, which is why I put it on a PowerPoint slide here, is that the numbers on the scales are very indistinct. So I'm going to go through them with you here, so then you'll get orientated when we look at the simulation on a video. First is that the time span is year 2000 here, 2050 in the middle, and it goes to 2100. These are global carbon dioxide emissions. They're in billions of tons, 10 billion, 20 billion, 30 billion. This is atmospheric carbon dioxide concentration in parts per million, 200, 400, 600, and 800 parts per million. Next one is the temperature change, the temperature increase from pre-industrial. In degrees C, 1 degree, 2 degrees, 3 degrees, and 4 degrees. And the top one is the sea level rise in millimeters, 200, 400, 600, rising up to 800. Now, I can't blame Climate Interactive for this, but there is one thing which is wrong with the presentation here. The simulation is perfectly good. It's excellent. And that is, of course, that we have the 2 degrees C global temperature increase target, the EU policy compromise target dating back to 1996, and that's clearly now a target for global climate catastrophe. James Hansen said several years ago that it was disastrous, and last year with some other experts he published a paper saying that 1 degree C is the limit. And of course it is, because as he said with the others in the paper, unprecedented disasters have been happening around the world for several years and attributed to climate change, global warming already. And even worse, up in the Arctic summer sea ice is in a meltdown situation 30 to 50 years before the scientists with our models had anticipated. And also, even worse, we have methane carbon feedback due to the rapid warming in the Arctic, emitting methane into the atmosphere, and so much of it that is driving up the atmospheric concentration of methane again. So because the 2 degrees C is the target, you'll see here that the target of the atmospheric, the stabilization goal for atmospheric carbon dioxide concentration is 400 parts per million, but I think most of us certainly agree with James Hansen, who wrote the paper a few years ago now, that target CO2, showing that we have to get well below 350 parts per million of atmospheric carbon dioxide to avoid global climate catastrophe. Focused on the all-important global carbon dioxide emissions now, and you'll notice that the graph seems a little strange because this is business as usual, and we see the emissions steadily rising up to 2050, and then they flatten out. Now, this is an assumption by the modelers. Their assumption is that by 2050, somehow automatically, without any policy measures, because this is business as usual without any climate mitigation, the modelers assume that automatically there will be a switch over starting from fossil fuel energy to zero carbon renewable energy. This is definitely not the plan of the world economy and the fossil fuel corporations, so that's a pretty doubtful assumption, but it needs explaining. So we'll now see what happens here with the business as usual as defined by the modelers. As the emissions increase, of course, the atmospheric carbon dioxide concentration increases, but the interesting thing is that when the modelers assume that the emissions are decreasing, the atmospheric carbon dioxide concentration continues to increase. And of course, this indicates the persistence and accumulation of carbon dioxide in the atmosphere as long as it's being emitted. Consequently, because atmospheric carbon dioxide concentration is greenhouse gas, it's heat in the atmosphere, the global temperature continues to increase, and its rate of increase also goes up a little bit faster than the atmospheric carbon dioxide concentration. And because the planet is continuing to warm and the warming is increasing, the sea level rise increases faster than anything else. And the sea level rise, of course, is a combination of thermal expansion and the melting of planetary land ice. Now we'll get going using the simulation. It's going to reduce our emissions from the business as usual rate of increasing emissions. The simulation provides us with some choices as regards modifying our carbon dioxide emissions. The first one is the 2009 proposals, the failed Copenhagen UN climate conference, and they haven't improved one little bit since. This is representing our commitment today due to the combined best proposals if all of them are fully implemented. As you see, what is most important is that it's a commitment to, according to this model, 4 degrees C by 2100. And that's been confirmed since by other studies that today we're committed by the best policies put forward by our governments of a global temperature increase of 3.5 up to 4.4 degrees C, I think it is, by 2100, and that's total catastrophe. For one reason, the IPCC says that all crops in all regions are into decline below the baseline at global temperature increase of 3.5, so the world will not be able to feed itself, but way before then, runaway climate change and rapid global heating would have occurred because of all the methane going up in the Arctic at such a temperature increase. So we're committed to climate catastrophe today. That's what that means. So the next thing is what happens if we flatten the emissions, if we've got what the scientists call constant emissions. We don't allow our emissions to go any higher. Right now they're being increased faster than they've ever been increased before. And the atmospheric carbon dioxide concentration keeps on going up quite significantly, and therefore the global temperature increase continues to increase, and the rate of increase increases. You can see that. So it hits this catastrophic 2 degrees C mark by 2050, even if we say we're not going to increase our emissions anymore. And of course the sea level rise continues to go up exponentially. So that's catastrophe. The next is a modest decrease. So this is a decrease of about 25% on where we started at year 2000. So now we're emitting less. The atmospheric carbon dioxide concentration, though, continues to rise. This is due to this reflects the scientific fact of the great persistence and cumulative property of emissions. Therefore, the temperature goes on increasing, and it's still hitting 2 degrees at 60. So that's hardly, well, that's certainly no better at all. Of course, that's still catastrophe. Exponential increase in sea level rise continues. The next choice is an 80% reduction. The simulation says this is an 80% reduction of global fossil fuel plus a 90% reduction in land use emissions by 2050. This model shows the carbon dioxide stabilized up to 2100, but in fact this is not long-term stabilization at an 80% reduction. There will be some slight increase later on before atmospheric carbon dioxide reaches stable equilibrium. The global temperature increase continues to rise at much the same rate as it started at. Exponential increase in sea level rise, of course. So at 80% reduction, there's no way that we've avoided catastrophic global climate change. And to drive that home even more severely, the fact is that a global temperature increase of 2 degrees C by 2100 commits all future generations to a temperature increase that's double that. In other words, that totally catastrophic 4 degrees C. And that's due to the inertia of the climate system, due to the ocean heat lag that's been known since the very first IPCC assessment in 1990. So the particular temperature at a particular time is only about 50%. The eventual full increase of the temperature that amount of greenhouse gases in the atmosphere will cause. So the final choice that we've got is a 95% reduction by 2020. So a 95% reduction, that is zero carbon emissions, that's virtual zero carbon emissions. 2020 is 2012 when I'm doing this. This choice is somewhat beyond the possible. Even so, there is just a minimal decrease in the atmospheric carbon dioxide concentration, and hence the global temperature still passes 2 degrees C by 2100, so that still commits all future generations to a absolutely catastrophic end of civilization, humanity, 4 degrees C, and the sea level has not stopped rising exponentially. So the lesson of this is that we have to realize the dire emergency situation that we're in. The only scientific target is clearly a 95% reduction of virtual zero carbon dioxide emissions. We must be developing rapidly the economic and technological capacity to achieve virtual zero emissions. The message is that we have to stop burning carbon, whether it's an 80% reduction that we aim for or a 95% virtual zero carbon emissions that we aim for. Both mean total conversion of energy supply from fossil fuels totally onto clean, zero carbon, everlasting energy sources, which we know are abundant.